Right, so just looking at an angle is considered to be in standard position if its vertex is at the origin. So the vertex of an angle is like the corner part. Its initial side coincides with the positive x-axis, so that's this. All right, that's a positive x-axis, that's the initial side. Right there. Then we call this the terminal side. So it starts and rotates around. It comes up, straight up would be 90. Over here would be 180. It comes down, rotates down here, that's 270. One complete revolution is 360, right? Just review stuff for you. Gotta get this going too, don't we? All right, that point where the vertex is the origin, right? 0, 0. Okay, we call this the first quadrant, second, third, and fourth quadrant. Okay. So 1 degree is 1/360th of a circle, right? 360 degrees. An acute angle is greater than 0, but less than 90, so it would have been in this first quadrant, right? Those are acute. They're acute because they're small, yeah. Right angle is 90, straight up and down. An obtuse angle measures greater than 90, but less than 180. That would be in that second quadrant. That would be, where this terminal side is here. That would be obtuse, bigger than 90, less than 180. So this terminal side would stop in there. All right. And then a straight angle is a measure of 180 degrees, halfway around the circle, right? Starting here all the way to there would be 180 degrees. All right, so stuff you guys already know. Just a quick review of that. Okay, so just to draw in standard position, a 70-degree angle. We've got our, x-axis and our y-axis, right? So in standard position, the initial side is this red side. The vertex will be there at the origin. And then I just go 70 degrees from here. So if I went straight up, that's 90, so it would be a little less than that. Somewhere in there. And then you just draw a little arc. You just label it 70 degrees. That's a 70-degree angle in standard position. Okay, and when you go counterclockwise here, that's positive degree measure. If I wanted to do the 290, okay, here's my initial side. All right, negative 290 means I'm going to go this direction, clockwise, right? So if I go straight down, I'm at 90, straight over at 180, straight up 270, it's a little past 270, so I'm going to go around till about there. And that's negative 290. What do you notice about those two? What do you notice about the red one and the green one?
The negative ones have little radius on the outside.
Yeah, but what if I just moved? What if I just moved this red one? Wish they would have stuck together. Yeah, they're the same, aren't they? Let's do this. Oh, I didn't want to do that either. Oh, come on. Anyway, what I wanted to do was put those together. Oh, that's going to take that. Anyway, if I were to move this red one on the green one, they'd be about it. They should be exact. Negative 290 and 70, those two terminal sides are at the same spot, right? That makes sense? All right. This C1, okay, the third one, let's go a different color. All right, we start here at 750, where we start our initial side. And 750 positive, so I'm gonna start going this way. One time around is what? 360. What would two times around be? 720. So that there's 720, how much further? 30 more, right? So it's gonna be about there. So that'd be 750 degrees in standard position. Okay? Just a little review of some stuff. Any questions so far? Pretty simple, right? All right. So complementary angles and supplementary angles, right? Two angles are complementary if their measures add up to 90, and two angles are supplementary if their measures add up to 180. Okay, so you're going to be given an angle, and you're supposed to find its complement, and then its supplement. Yes, sir. Yeah, we did well.
Very good.
Yeah, thanks.
Good news.
Okay? So let's just pick a couple. Morning, Mason.
Morning.
Thanks. So if I gave you a 36-degree angle, what's its complement and what's its supplement? So what would I do to find the complement? Matt?
I don't know.
Well, what are the two supposed to add up to if it's their complement?
360.
No. Complements add up to
90.
90. So all I gotta do is go 90 minus 36. So what's that?
54.
Yeah, 54 degrees. Okay, Jagger, what about supplement?
180, right?
Yeah.
130.
What's that? 144 or 34? 44, right? Okay, so you'll have a few problems where they're gonna ask you to find the supplement or complement, okay? So all I gotta do is 90 minus whatever it is, and 180 minus whatever it is. Okay? All right, getting to a little bit, something different, radians. All right? Most of the time we talk about angles and degrees, but when we start talking about trig, we talk about radians as well. It says a radian is a measure of a central angle, right? So you'll see this symbol, that's called theta. Okay, a central angle is when the vertex is at the center of the circle. Okay, that intercepts an arc length S. And then our radius, remember, is half, from the center to the edge of the circle. Radius, all right? So the arc length divided by the radius, we can figure out. But a radian is when the arc length equals the radius, all right? So, this is, if I put this R like this, let's see here, if I draw something straight up, that's R, and then I fit it to this so that it would, kind of go right along the edge. So we got all these R's here. Okay, that length, the radius length is the same as that arc length. Like I took this and just laid it on there. That's what a radian is. Okay. So I could probably get, if I went straight across here, I could probably get, 3 R's and there'd be a little bit less than 3 full ones. There'd be a little part of this that wouldn't work. Wouldn't quite fit. It's a little short. 180 is halfway around. Okay, so a radian is just how many radii I can get around the circle. Okay? So a lot of kids say, what is a radian? So I wanted to try to explain it to you. Just how many of these lengths, whatever the radius of the circle, can fit around the whole circle. Okay? That's all it is. So sometimes they'll ask you to put your answer in radians, and sometimes they'll ask you to put it in degrees. What we're going to learn is how to change from one to the other. That's what you're going to be asked to do. Convert from radians to degrees or degrees to radians. Okay, but I just want to kind of let you see a visual what a radian is. Okay, so this is just a conversion that they do. All right, so one full rotation is 360, half is 180, right? And if I were to do this, look at R like I was doing, there'd be almost, 6 of these. No matter how big or how small your circle is, there will be 6, a little over 6 of these radii that would go around the whole thing, or radians. Okay? And if you were to do a conversion, the circumference all the way around a circle is 2 pi r, right? That's the formula for such circumference. Okay? So if I divide it by 2, 180 is pi. If my radius is 1, if I would do a radius of 1, that would just make those equal. Right? If r equals 1, then those are equal. And that's what 180 degrees is. It's pi radians. That was bad. All right. So the conversion is 1 degree is pi over 180 radians. 1 radian is 180 over pi degrees. So that's the fraction we'll use to change from degrees to radians or radians to degrees. Okay? So we're going to remember that, those two fractions. All right, so if I got 60 degrees and I want to change it into radians, I'm going to multiply by pi over 180. So the degrees get canceled. You can just put this over 1 if you want. Usually what I do is this. I make a bigger bar for my fraction, and I just put pi up there. And then I reduce that fraction. So basically when you're going from degrees to radians, you're just dividing by 180, whatever the degrees are, and putting pi in your numerator, or right next to it if you want. So what's 60 over 180 reduced to? What happens to the zeros? They cancel, right? What's 6/18? How many times 6 going 18? 3, right? So this would be 1 pi or pi over 3. A lot of times you'll see it like this. Pi over 3. They won't put the 1. You know, a lot of times we don't use the 1 as an exponent or as a coefficient. Okay? So for the second one, I just do this. And then I reduce that. Okay? And if you divide 180 by 4, or by 45, you'll get 4. 45 goes into 180 4 times. So that's pi over 4. And we don't usually write the word radians afterwards. We just leave it like that. You just understood that it's radian. Okay? For C, just use negative. It's okay. You're just going the other way. And it's going to be pi. Right? So here's what I do on my calculator, my graphing one. So I go 225 divided by 180. And then I hit math and enter twice. So it's 5 pi over 4. But what did I forget? I forgot something. What did I forget? Negative, yeah. Don't forget it's negative because the negative was there. So it's negative 5 pi over 4. Okay? So if I were to draw it, remember I'd be going this way, right? Be up there somewhere. I drew it. Okay. So all we're doing is changing from degrees to radians or radians to degrees. So we okay with degrees to radians? Just divide the degrees by 180 and put pi in your answer, the numerator part or next to it. You know, this is okay too. Sometimes you'll see it like this. That's okay too. I usually just keep it in the numerator. Going the other way. All right? So what you do this time, because what do you want to happen with the pies? What do you want to happen with the pies? What's going to happen there? We're going to cancel. Yeah, it's going to go away. Right? And what was in front of that pi? There's no number. 1. So what's 1 times 180? 180. So that's 180 degrees, halfway around, right? That's what pi radians is. Okay, 3 pi over 4. Again, I wrote it with the slash, but I like, you know, on my paper, I would have done it like this. So that goes like that. Okay. And then 3 times 180 is 540 divided by 4 is 135, I think. Someone check me. All right, thanks. Okay. So once you do that, you just go to 2 numerators, multiply them, and then divide by the denominator, okay? This one, again. So the pi's go away. Then you just go 15 times 180 divided by 8. 15 times 180 divided by 8. So 337.5. Sometimes it won't be a whole number, that's okay. Decimal's okay. You guys have done this before. It's been a while, maybe. All right, so complementary angles add up to 90, supplementary angles add up to 180. All right, if you have to draw an angle in a certain, in standard form, just draw your little arcs. Remember, clockwise is negative, counterclockwise is positive, initial side, terminal side. All right, changing from radians to degrees, you go 180 over pi, degrees to radians, pi over 180. Basically just divide by 180 and put pi in your answer. Okay, I think that's it for today. Yep. All right. So one and the first four just changing from finding complementary and supplementary angles. And then 32 to 60 by 4s is degrees to radians, radians to degrees. That's all it is. Not that much. It won't take you long at all.